Welcome back to the channel. In this video I'll be working on my 2004 Chevrolet SSR pickup. It has a 5.3 liter LM4 V8 engine. What I'm trying to accomplish in this video is to replace the intake manifold gaskets, the intake manifold itself, and I'm swapping out the fuel injectors as well. There's a variety of electrical connectors that need to be disconnected from the throttle body mass airflow sensor, some hoses from the throttle body, going to the coil packs, the fuel injectors, the map sensor on top of the intake manifold, the evap purge solenoid, the alternator. So getting those all disconnected will allow you to lift the wiring harness up, and I suspend it with a couple bungee cords going up to the hook on the hood to keep that up and out of the way, some vacuum hoses, and then you've got some fuel lines after you disconnect the fuel injectors as connections themselves, and then you need a special tool for the fuel lines, and then 10 bolts come loose and you can lift it up and out. I replace the gaskets and get the replacement manifold ready to go in after I swap out the fuel injectors. So let's get to it. So I'm going to be swapping in these fuel injectors. I've already replaced all the O-rings on them, and I'm going to be using the fuel rail off this particular intake manifold since I recently replaced the fuel pressure regulator on this particular one. I wanted to make sure I didn't disturb the seals on that, so I'll be retaining the fuel rail from this one. So I'll be taking the 8 injectors out of this rail, putting these 8 in, and then swapping in the other intake manifold, put this fuel rail back in, and then put it all back together. But the first thing I want to do is I've let it set overnight. I have hopefully decreased the fuel pressure to near 0. I'm going to attempt to start the engine after I've pulled the relay out of the fuse box, which we've seen in a couple other videos here. So I'm going to be attempting to start the engine without the fuel pump relay in place, so that will hopefully drain out whatever residual pressure or fuel might be in there'll still be fuel in there. I just want to make sure I drain out as much as possible. So let's go ahead and do that now. You can also remove the cap that's on the fuel rail Schrader valve where you normally would connect a fuel pressure test gauge, and you can press on the middle just like you would for a tire valve stem and relieve the pressure that way. As I suspected, there's no fuel pressure in there, so I just want to make sure that there wasn't any, or I reduced it as much as possible so that when I start pulling things off here, I don't get into a spraying situation of fuel. I will still have some in there, so I'm aware of that, but we'll put some rags down to collect that and make sure to put that into a well-ventilated area. I'm in a well-ventilated garage area at this point in time. I've turned off all ignition sources in the near area, so this is a safe environment to begin this process. So a couple things we need to remove. We're going to have to, of course, remove the throttle body. The studs that are in here as well need to be transferred over. So I'm going to take this throttle body air intake from the air cleaner area off. I'm going to be taking this plate for the decorative SSR engine cover off, and then I'm going to be loosening these connections for the various wiring harness items on the top of the intake, and then disconnecting the 2 fuel rail connections to the high pressure input and also the low pressure return to the fuel tank. And I have some special tools for that. I worked on this vehicle several years ago, and I bought these Lyle, I believe I'm saying that correctly, but I believe it's that one that I used before, to insert in here to release the catch, be able to take that off correctly, and then we'll be able to pull this off. Again, that'll probably be the place that the fuel most likely will be coming out, so we'll leave that for a little bit. We also have to remove all the connectors to the fuel injectors for the electrical side, 4 on each side. And then we have the 4 bolts on the total of the fuel rails, 2 on each side. And the intake can come out without as an entire assembly, so I'm going to leave the fuel rail till after I get out, but I do have to get the fuel connections disconnected, of course. And of course we have the emissions, the PCV line from the passenger side valve cover that has to be disconnected. That's simply coming off there. And then the connector at the back of the intake is somewhat difficult to take off, so I'll be disconnecting it here at the brake booster, and the other intake also has that same hose on it, so it'll be easy swap there because I'll just retain the one on the other one and use that. But we've done the fuel pressure depletion step, so let's go ahead and start removing the items here to get this fuel or the intake manifold out of here. First off, we're going to squeeze this connector, or actually, I'm sorry, Move down the gray lock. That exposes the black connector tab, and that removes that out of the picture. And then I'm going to loosen it here, and I'm going to take these two Phillips, loosen these two Phillips here so I can take this out as an entire assembly so I have more room to work with here. Lock this off the throttle body input intake area. Okay. Remove the top radiator hose from the shelf on the back here. And then this should come out. Now there are 3 nuts on the throttle body, and then there are 2 hoses that connect here. And close this off to the overflow tank, surge tank, and to the top of the block there. So let's get those closed off. Looks like that's an e-Torx, so let's get those sockets out. We need to transfer those over to the new intake, or replacement intake, it's not new. E5 socket. And okay, make sure we're going the correct direction. We seem to be. So the thing right behind us here is the evap purge solenoid. And we need to disconnect the electrical connector. There's a little tab over here. This is a very loose thing up here. I never quite felt comfortable with this. So let's wiggle this out. So we have the electrical connector out, and if I recall correctly, press this to one side to disconnect that. And then there's a 8mm. Okay, there's the bolt with the shoulder on it, and the solenoid itself, but there's this plastic piece here. So you wiggle it out, there's an O-ring at the base of it, and that kind of goes over the edge. So this looks in good shape. This will be transferred over to the other intake as well. So we'll need to move that out of the way here. Looks like I've got a zip tie there, so I'm going to disconnect that. That's been separated. There's also a zip tie around the fuel rail here, so I'm going to disconnect that. Those are probably added by myself to stop it from vibrating around without any real strong tension on them. Okay, that appears to be freed up. Now we need to get that plate off the top. Make sure we're going the correct direction. Plate can't be transferred over yet because we have stuff to move over and install, so I'm just going to put the bolts over on the new one so that we don't lose which locations to go into. So we have the wiring harness that goes through and gets taped here, so we need to remove this 10mm nut here. We have the manifold pressure sensor, the map sensor here, so we need to disconnect the electrical connection and transfer this over to the other intake. And then once this is disconnected, we should be able to lift this enough to bring the intake out, because I've done this once before and that worked. Of course, back here in the corner we have that PCV related hose, which I've disconnected. We have the fuel pressure regulator vacuum line, which we're going to disconnect for now. Actually, we'll do that in a moment when we get the whole thing out and I switch over the fuel rails. So right now, I'm going to remove that 10mm nut. There we go. Looks like this stud and nut are already present on the other intake manifold, so I don't need to transfer it. Let's put it in place here so we don't lose it. And let's get the map sensor electrical connection. We lift the gray lock upward and then wiggle that back. And then that's disconnected. And then there are two clips, fairly loose clips though. I found, the same thing with the fuel tank pressure sensor. It's a very loose locking system for it. There we go. Let's look at the seal on that. And that appears some oil residue, which you would expect inside the intake. Seal looks like it's in good shape. So I'm going to transfer this over to the other intake manifold by lubricating the seal and walking it back in and snapping it in place. Now, if I recall correctly, this connection is for the knock sensors underneath the intake, which I replaced when I took the intake manifold off last time, because I did have some leaking intake manifold gaskets back then. That was about 4.5 years ago. So there is a clip here we need to disengage. And the harness goes adjacent to the brake booster vacuum line, so it's not exactly the easiest, and I don't want to break the back end of that, so I'm going to leave that in place. But I am going to remove the end here like that, so it's separated from the vehicle. To remove the electrical connections on the fuel injectors, there's this lock on the side that you have to pull up. Oftentimes it'll actually pull out all the way, but I believe you only need to get it up to the point where you can then depress the lock tab here to disengage the lock against the fuel injector itself. I have my protective eyewear since we're dealing with the fuel part of it now, and I'm getting some gloves on. I took the other PCV line off near the throttle body connection here, so that's off to the side. Next thing I'm going to do is I'm going to put a rag in here, and then I'm going to try blowing out any dirt that might be occurring on the top of the engine block. Alright, the fuel rail is still connected here, so let's get these other tubings out of the way for the moment. We have these two clips that we need to remove, and I'm going to mark these so I just don't get them confused in case they're not the same, they're different sizes. I'm going to put the blue tape on the top one. Just in case it's not obvious, so the blue is on the top. I could write on it, in fact, let's do that. And before we start disconnecting anything, let's get some rags underneath that. I don't know if this is too wide. Let's see if we can, that's the lock for the top. I marked this one with a T just in case they're different or same, or I'm not sure. So let's remove the two locks. Looks like the markings are the same. And this is where I'm going to need that release tool that I showed you earlier. You need to insert it here to disengage the internal locks here so you can back this off. So let's feed that around, step that in, and this should allow this to come off. There is some fuel there. And let's do the same for this one on the bottom. We have the two fuel lines disconnected from the fuel rail. All right, we have this, which I believe we end up needing, we need to disconnect. So we'll disconnect that as well. Again, we need to be careful as we lift up on this. We have to snake that around the vacuum hose for the brake booster. So the fuel rail is fully removed as far as connections to the vehicle. All the electrical connections are done. As far as being disconnected from the fuel injectors, we have the two fuel lines, the high pressure and the return, disconnected. I'm going to reuse this fuel rail. The reason being, again, I already have this fuel pressure regulator I just recently replaced, so I don't want to take it out and cause any potential leaks. Plus those particular connectors are seating well with the O-rings and everything in those lines, so I don't want to take any chance of them not mating up well with the ones on the one from the other intake manifold. So we'll be getting that out. So next we have to remove the bolts that are holding the intake manifold to the cylinder heads, and I believe that is an 8. Yes, an 8mm.
To facilitate the removal of the intake manifold, I'm going to loosen the 10 bolts, 5 on each side of course, and then disconnect the wiring harness fully on the passenger side and driver side to allow it to be lifted up so I can remove the intake manifold. With the intake manifold removed, I now have access to clean the cylinder heads, making sure I don't get anything into the intake ports. And then you can see in the center there the NOx sensor covers and then the red RTV around that. That was a recommended procedure to help divert any water, if any were to get up there, around the NOx sensors to have it flow backwards. So once we get this cleaned up and get the other intake manifold ready, we'll get it installed.
I have the replacement manifold with the new intake gaskets on it, and there are 2 bolts already in because they were challenging to remove, I believe for the previous owner or tuner or whoever removed it, because they seem to be difficult to pull out. So I've already put the Loctite thread locker on it, blue. So That's certainly a lot easier to install with the fuel rails out. So let's see if I can get some threads started at least here. Okay. And as I install these bolts, I'll put the Loctite on them. I'm gonna lightly snug these in, and I need that. We're going to be torquing the intake manifold to this spec. I'm just bringing them down to where they're just touching with this at the moment. The first pass is 44 inch-pounds, and we start over on the passenger side. We go basically from center out, much like you would expect, like you would torque the heads or anything like that. You work center outward. So 44 inch-pounds, 44. I've got that set now. Alright, all 10 bolts have been tightened to 44 inch-pounds, so now we're going to change it to 89. Alright, let's bring in the fuel rail. Alright, the injectors, I lubricated the O-rings on the injectors so that they would go down into the intake manifold nicely, and they've all seated. We have it across the top of the intake manifold. They're seated on this side as well. The evap tubing is clearing. And let's see here. There we go, that's on the outside. Check valve in, brake booster, it's in. We have the knock sensor connector in place, and let's put this in place while we're here. Alright, I'm going to put the fuel rail bolts back in place. Move that a little bit. That's fully engaged. I'm going to reconnect the fuel lines at this point, lube them up a little bit so the O-rings can go over nicely. This is the top one. Let's do the bottom one first. Let's pull this PCV line just out of the way for a little bit. clamp on. Clamp on. Take our tape off because we no longer need it, so those are on. Alright, I can start laying the wiring harness back down because we have all the bolts on the intake manifold tightened. We have the old fuel rail with the replacement fuel injectors in place. 4 bolts for those are tightened. We have all the evap and PCV line is stick off back here. Let's put that on. And now we can start laying the harness back down and reconnecting things. So let's Alright, let's start bringing over the passenger side here and laying this down so that it sits across the top of the intake manifold.
We're going to reconnect the coil connections, the fuel injector connections, the AC pressure sensor on the front passenger side, and the alternator, and make sure the map and purge solenoid are reconnected.
Clean this area up one more time. We have a hose to reconnect up here. I see I've missed that. These studs are supposed to be torqued to 53 inch-pounds. Now I'm going to put the throttle body back on. The gasket is 17113561. It's all in place and seated. Alright, let's get the throttle body on here, making sure this is clean. We have the cooling hose that goes through it's a heater hose to heat up the throttle body through there. We have the throttle body studs torqued to 53 inch-pounds, the nuts torqued to 89 inch-pounds, the electrical connector is back on. We're getting to the point where we can put the air inlet to go on. Alright, let's get this back in place. We have to make sure we get the hose up on the shelf again. There we go. Alright, let's do a quick run over of everything before we attempt to activate the fuel pump to get pressure up in the fuel rails to look for leaks. So we have the purge solenoid tightened, evap line connected, electrical connector connected, alternator connected, the coil main plug on the driver's side is connected, the 4 individual injector electrical connections are in place. We have the fuel pressure regulator vacuum line back in place, and we have the PCV vent on the valve cover side on the driver's side reconnected. That was already connected on the top here. We have the 4 electrical connections to the injectors connected here. We have the coil connection reconnected. We have the electrical connection to the pressure sensor for the AC line, I believe that's what that is. And that's back in the harness area there. We have the throttle body connector reconnected. We have the mass airflow sensor connector reconnected. The coolant, basically heater circuit and air burping for the top of the block and reconnected through the throttle body. And that's an 0304 specific thing. The 0506 with the LS2 didn't have that feature. It just still had the connection here piping, but it didn't have the going through the throttle body. And we have the mass airflow, the pressure sensor, MAP map sensor up here reconnected and installed. And these are sitting in their normal grooves here. This is tightened. The knock sensor connector is reconnected and attached to the intake manifold where it normally rests underneath the decorative cover. Fuel lines are reconnected. I had the one that was marked top back on top. It's got the clamp on here to keep it in place. I have the lower one in place as well with its clamp. I believe we are at the point where we can check for fuel leaks. So I'm going to go ahead and put my relay back in place. Putting in the proper orientation, I have an arrow marking towards the front. So that's back where it should be. Let's put this cover back on where it should be. So I'm going to turn on the key to start pressurizing the system. Initial fuel pump pressurization after installation. It's not continuously running, but at least it should start to pressurize it. I don't see any gushing leaks anywhere, so.
The engine started, but there were 3 cylinders with misfires. I was able to detect 2 of them with my scan tool and found that after I replaced 2 of the injectors that I had just swapped in, those were better. I still had P0300. So I swapped out the fuel injectors with brand new ones, and let's check out that video now. I now have my replacement fuel injectors on the top of this freezer I'm using as my workbench at the moment. And what I'm going to be doing is testing their resistance and also checking to make sure that they actually open and close. Here are the 2 fuel injectors that I removed from the vehicle. Actually, I swapped out all 8. I had cleaned these, and I thought I didn't have a good test apparatus at the time. This isn't a great one, but it's a 9-volt battery with some test leads, and I found that these don't actually open. If you apply power to these connectors in here, you won't be able to actually get any clicking out of it. And I'm going to verify that those open and close with this 9-volt battery test. I'll be creating a little bit better test harness for this. I've ordered a pigtail to plug into these. I'm going to try to get these cleaned and the original 8 that came out of the vehicle, but I'm not going to mess with it anymore. I just want to make sure I get 8 good fuel injectors in there, so I've got 8 brand new ones, but we're going to at least verify that they're functional before we try to swap them in. So the first test we're going to be doing is the resistance test to make sure that they're all consistent as far as their resistance. I was finding between 12.6 and 12.9 ohms. So let's get this to ohms.
And again, that pigtail would be really great in performing this test, but so I'm going to go through each of these and verify that their resistance is consistent and similar to what I've seen before. Just applying to the test leads here. 12.3. So the ohm resistance is reasonably similar. There is a variation between 12.4 and 12.9. I've seen a similar range on the original fuel injectors and the replacement ones as well. In fact, this is one of the ones that doesn't actually open and close. And before I installed it, I actually did this test. See, it's got a good resistance value. As does that one. They're very similar, so the electrical part of it is okay. But if we try to do the activation test, I have successfully used the 9-volt battery to test the injectors. In fact, let's test one of the new ones first so you can maybe hear the actual clicking. Let's see if I can get this stood up to where it's going to be helpful here. Yeah, I can hear it clicking. Now with one of these, you'll hear nothing. I can see little sparks there where I touch the contacts, but there's nothing. So there's no movement on that injector. Same on that injector. So these were in cylinders 7 and 8, and those were the misfire cylinders I was seeing before with my scan tool. I'm now seeing it in cylinder 1 and somewhat in cylinder 7, I believe. If we look at the firing order, actually I think it's cylinder 8. So 1 is misfiring all the time, and 8 is partially misfiring. That may be a carryover from the 1 complete misfire. So what it appears to be is these are stuck closed and not supplying fuel. So I shouldn't be flooding the cylinder, but still it's not working right. So like I said, I didn't want to mess around with any more used ones since I had in question the viability of my original injectors while they were hot on a deceleration. They may get stuck open or closed. At least that's one of the premises I'm trying to test here. So now we're going to go ahead and do the open and close test on the new injectors to make sure that that works out on all of them. So I make sure I got injectors that will open and close. Yep, that one opens and closes. So let's just repeat this test. So all 8 of the new injectors, the solenoids react to power supply, so that's a good indication that they might work. And the resistance is within spec. Now if one of them or a couple of them were like 20 ohms or something greatly off the normal that we were seeing, or the average that we were seeing there, so they're all within about half an ohm, and that's reasonably okay. So I'm going to go ahead and start stripping out the fuel rail and get these 8 new fuel injectors installed. I have the fuel injector that was in the vehicle. That was one of the replacements, the original replacements, not the new ones. And this was in cylinder number 1. I want to see if it activates at all. Based on the sound. Nope. So that's the third of the 8 that wasn't functional in that batch. All right, just wanted to confirm that this fuel injector that I had in the number 1 cylinder wasn't functioning, and it was not.
Now here's the video for me pulling the fuel rail out of the vehicle so that I can pull out the 8 replacement injectors that I installed in the earliest section of the video. And unfortunately, as you saw, I had 3 injectors that were stuck. They were used injectors that had been sitting around for a while. I used some injector cleaner. I thought I had let it sit in that cleaner long enough to make sure it was functional, but I missed the simple step of simply attempting to activate the solenoid. So you saw how to do that in the previous section. I would prefer to do it with a test harness that was a little better. I did buy the fuel injector pigtail. That'll make that a little bit easier going forward. But learn from my mistake. Make sure you check not only the resistance of the injectors, but also activate the solenoids to make sure that they sound viable before you install them. So in this process, you can see that pretty much the same things are done to remove the fuel rail, except of course you don't have the bolts. You don't loosen the bolts for the intake manifold, just the 4 bolts for the fuel rail. But you have to get the wiring harnesses and evap and PCV lines out of the way just so you can lift the fuel rail out. Make sure you remove the 4 bolts to secure the fuel rail to the intake manifold, then pull upward and they should pretty easily pop out. Make sure you lift up and don't touch the fuel injectors on the bottom against anything as you're pulling it out. Lube the O-rings before you reinstall it and secure the fuel rail with the 4 bolts again and get your vehicle up and running. Well, there you go. You've seen the removal of the intake manifold, the disconnection of the electrical connectors, the PCV lines, evap lines, and the necessary steps to get the fuel rails disconnected from the fuel lines coming up from the tank and the fuel pump. So hopefully that information is helpful to you. If you want to try to tackle this task, make sure you have a well-ventilated area, protective eyewear and gloves to protect your skin from contact with gasoline. So if you found this information helpful to you, make sure you hit the like button, subscribe to the channel if you haven't already. Make sure you hit that bell notification to be notified when I upload videos like this to the channel. Please consider checking out my other Chevy SSR videos. Check out my project car videos for my Chevy Caprice PPV. Thanks for watching, and I'll see you in the next one.